So here's a short extension. Suppose we take that same problem we were just dealing with and decided to take the shaded region and revolve it around the x-axis. Well, if we do that, that would leave us with a solid round shape that would then have a hole in the center from where this hole is here when you are revolving it around the x-axis. So instead of using rectangles to find our area, if we sliced it up and down all the way through, really it would be like a thin washer with a hole in the middle from this. Well, when you think of finding the volume of a washer like this right here, basically you got to take the outer circle times your thickness, which is h, minus the hole, which is your inner circle, times your h. So you could pull your h out. Basically, it's the big circle minus the small circle, all multiplied by h for your volume. Now, because we're in calculus and we're integrating, our thickness of h is really your dx. And so we'd have to go pi times your radius squared. Well, your big radius would go from here all the way down to here. So in other words, that's your big function. And notice it's big radius squared for the area of that circle. Big radius squared for that area of the circle. Still multiplied by pi. Minus, we got to do the whole. Well, the whole goes this open spot, which is your blue function, back down to your axis of revolution, which is just your blue function. So your small radius is your blue function. And we have to integrate this with respect to x. So that means we're going in from 0 all the way over to here. So your bounds would be 0 to a. So in other words, you could just type this into your calculator as you see it on your home screen, like we did at the very end of the last video, and you should get about this here. Now, second extension is, suppose we have that same shape, except we're going to try to do squares coming out of this. In other words, you would have a square where you would have the bottom edge of a square here, and then you'd have a square coming straight up out of your screen, that same height that we just drew here, where over here your square would not, oh, why didn't it do that? We'll try that again. We do our square here. That's a much smaller square because it's not as long there, so it's not going to come out of your screen nearly as much. Or if we do our square here, that's a much longer distance. It's going to come much farther out of your screen. It's going to be a very unique shape. And we're going to show more of this when we get in class. But if we did squares, you got to think, oh, how would I find the area of a square? You should know that the area of a square is just your edge squared. So it's your edge squared times your thickness. Well, once again, in calculus, we're integrating. Our thickness would be a dx. So we're still going to be integrating all the way from 0 to a. And the area of a square, once again, is your edge, all squared. Well, our edge goes from the red down to the blue. In other words, it's the red minus the blue for your edge of your square. So the edge of your square is the red minus blue, and because it's a square, we then have to square it. So we got to take and square that whole thing. So we have to take the red function minus the blue function. And then you'd want to go ahead and square that whole thing. If you type that all in, then you would get this shape here. So that's a quick extension. We're going to be doing more of this in the rest of the chapter, but I just thought I'd do a little bit of an extension here for you.